Hello again. Welcome to the third lecture of the software engineering course at UL. In the previous two lectures, I started with the first chapter of the course. I explained for you the general concept of software engineering. We talked about why software engineering is important, what is the need for a software engineer in a company. We talked about the various types of software that a software engineer can develop and the difference between these types, and how each software is dedicated to a certain managerial level in the company. We also talked about how to integrate new technology within a company and use new type of software, new type of tools to develop new software. We talked about the roles of the system analyst or the software engineer, about the role of the project manager and his relationship with the software engineer. Finally, the last thing we talked about in the last lecture was about the software development life cycle, or the SDLC. As I stated before, the SDLC is one of three different models that are used to model or design a certain software. You can use either the SDLC, the Agile, or the object-oriented modeling using UML. These are the most used frameworks or methods to model and design a certain software project, and to develop the design of the project from its requirements collection until the actual implementation of the code of the project and the deployment of the project in the company and the assessment and monitoring of the project. So all of these three methods, they have advantages and disadvantages. In this chapter, we talked in detail about the various steps, the various phases of the SDLC. We are going to focus more on UML and Agile. These two are the most used frameworks for developing software in our days. We're going to talk about them in details in later chapters. We are going to dedicate a complete chapter for each one of the other two modules, which are Agile and UML, object-oriented modeling using UML. So last time I finished my lecture with a discussion about the relationship between the resources that you put into a certain project and how these resources vary with time. I stated that at the beginning you put no resources, then the resources will increase, the time and money you put into the project will increase until the deployment day, when you actually start working, implementing the project and working using it in the company. After that, the project will require maintenance. The amount of maintenance will decrease until the project is stable. After that, the project will become a little bit stale, and new features will be needed to insert it within the project. So the business requirements will change. You will need to insert new requirements, new features into the software, which means that you are making more changes to the project. So you are putting more time, effort, and money into the project. This will continue to increase, starting from the stable point until the project becomes too much stale and becomes too much old. At this point, you might consider changing the whole software and starting with developing and implementing a new software to replace the current one. So this is a cycle that continues, as you can see, indefinitely. Now let's continue with the remaining of this chapter. The first thing we are going to talk about is the importance of maintenance. Maintaining current deployed software is very important. What do we mean by maintenance here is two things. I will describe them in the next slide. In this slide, it's important to show and discuss what some researchers deduced that in many software companies and many companies in general, if you are implementing a set of software to run the various operations of the company, the amount of effort and resources that you put into maintaining current systems correspond to approximately about 60% of your total resources and effort, while the amount of efforts and resources you put into developing new projects, new software, correspond to about 40%. So this shows you the importance of correctly maintaining your current systems and software to a high degree. What we mean by maintenance here is two things. First, the first thing that maintenance is responsible for is to remove all errors that occur or are discovered in the software. Whenever you implement any software, you cannot expect that it will not produce it will produce no errors at all. You will never expect any software that it will run perfectly in all conditions and all situations. Each software will have its bugs. Now, the difference is that some software might produce small errors in very rare conditions and situations, while other software might produce more errors, more frequent errors, and other software might produce more big errors that require huge changes. So this is the difference between a software in general, but there is no software at all that is completely perfect in all conditions and will run smoothly and perfectly in all situations. So removing the errors, whether they are frequent or not, whether they are big or small, is an essential maintenance functionality that should be performed always on all software. The second type of functionality that should be done by maintenance is to enhance the software by incorporating and adding into it new features. When you deploy and start using a certain software in any company, at the beginning, the business requirements, the software is designed and built and developed according to the current business requirements of the company. So the company will be doing certain business operations, and the software will be designed according to the current business requirements. But as you all know, the business requirements, they are not static, they are not fixed. They will change over time. So as time goes on, the business requirements change. The society will change, the business operations will change, new type of business services are developed. So in general, the business requirements and business operations of any company will develop and change over time. This means that the current software that is deployed by the company should always also be enhanced and developed and changed to incorporate and add into it the new requirements that develop and appear. So over time, the cost of continued maintenance, so as time goes on, you will find yourself putting more maintenance into any software. You will find yourself correcting more errors. You will find yourself putting new features and adding new patches to the software. When this is done to the software becomes large and complex, which means that more errors will be produced. So you will be putting more cost, more efforts, and more time into maintaining the software. You will reach a certain point until when the maintenance of the software becomes more costly than developing a new software. At this point, it becomes more feasible to perform a new study in order to develop a new system, a new software, and to start a new project that will create a new software that will replace the current software. So we talked about the three approaches or three models that are used to design a certain software. I said before, we have the SDLC, we have the Agile, and we have the object-oriented model using UML. In this chapter, we are going to describe fully the SDLC. I already did that in the previous lecture. We are going to take a brief look at Agile and at object-oriented modeling. This will be done in the remaining of this lecture. However, towards the end of the course, there will be a dedicated chapter for each one of these, for each one of the Agile and object-oriented modeling. So we will take a complete chapter that will describe completely the comprehensive operations and characteristics of each one of these two types of software modeling. Before I go into the brief description about Agile and UML, I will describe to you the notion of computer-aided software engineering, or what they are called case tools. So if you search on Google about case tools, you will find a lot of information. Basically, computer-aided software engineering or case tools, they are software tools. They are used by software engineers to help them produce the required design and plan and documentation of the software more easily. So imagine that you want to produce all the design and all the documentation and all the data manually, then this will be a very tiresome job, and it will require from you a lot of effort and the time to produce all of this data manually. That's why case tools are specifically designed and tailored to meet the requirements of the software engineer. They help the software engineer produce drawings that will show a certain specific parts of the design of the software. They help the software engineer to produce animations that will describe to the customers and to the employees the specific features and how they are implemented. Also, with respect to documentation and data saving, there are specific case tools that help the software engineer to document the software and to save the data related to the software in an efficient and easy way. So generally, the reasons for the software engineer to use case tools are mainly to increase the productivity. Productivity is related to the amount of effort you put into the software in a certain period of time. So the more product you can produce, or the more functionality you can produce within a certain amount of time, this means that you are producing more. So this leads to more productivity. So case tools, they help the software engineer to be more productive, to increase the productivity of the software engineer. Also, another objective, another advantage of using case tools is that they can improve the communication between the software engineer and the users of the software. So whenever you are designing a software to be used by the employees of the company or to be used by the customers and clients of the company, when you want to describe to them the design, if you do that manually, this will be a very complex job for you. The case tools, they allow you to communicate and to express the design of the software to the users, the clients and the employees more easily, because it will generate a description and illustration of the design of the software in a more user-friendly and easy to understand way. In addition, computer-aided software engineering or case tools, they can be useful for integrating activities of the life cycles of the software, which means that as we saw in the phases of the SDLC, you will work on the design of the software in several steps or several phases. Now, if you want to connect various phases together, as case tools will help you in this connection. They will help you to connect the various steps or various phases together by integrating the outcomes and the inputs and outputs of various phases with each other. There are many classifications of case tools. In the book, we are going to talk about certain specific classification, which is whether the case tool is an upper case tool or a lower case tool. You can find other classifications if you search about case tools on Google. So there is a nice website. If you look about these tools at Wikipedia, for example, here you will see all the information you need to know about case tools, why they are used, how they are developed. So here, for example, the case tools are classified into a different classification according to their functionality. what do they do? Here is a description about the environment that is used for each one of the case tools. Okay, also the Wikipedia web page about case tools describes the information about uppercase tools and lowercase tools. If you look about them, think here, yes. Okay, so, and also the outputs of case tools, the different diagrams that can be drawn using case tools are stated. So if you are interested in knowing more information about them, you can refer to this Wikipedia web page about case tools. In general, we classify case tools into either uppercase tools or lowercase tools. The uppercase tools, they are used at the high design of the project. That's why they are called uppercase tools. When you are looking at the design from a high point of view, you use these uppercase tools, which means that if I want to create or modify the drawings, the required drawings of the system design, of the software design, I want to create the drawings of the database, for example, or the interface with the user. So instead of sketching this drawing manually with hand, I can use uppercase tools to create such drawings and to generate information, metadata about these drawings. On the other hand, lowercase tools, they are related to the lower part of the software design, which is to generate the source code of the software from the design. So there are many tools that they take the various design considerations. They take the various design outputs that you have done, the various drawings, the various data that you have gathered, and they produce from this design, especially from the class diagram that we are going to talk about, they produce from the design the different classes and the packages that contain these classes of the software. So you can generate the software code, the code of the software automatically by using the lowercase tools. One of the so in our course we are going to use various case tools. One of the main case tools that we will use is the eDraw software. Those of you who have taken database with me before, they know about the eDraw. We used to draw the entity relationship diagram, the ER diagram, using eDraw. eDraw is a very simple and efficient and easy to use software that allows you to create different types of drawings for different purposes. It contains drawings for maps, for database, for example. And in addition to that, it contains drawings that are used in software engineering. So if you look here, for example, at project management, okay, you will find there are some drawings related to the project management that we will be taking and using in the course. Also, if we take a look at business diagram, there are various types of business diagrams drawings. We also we will talk about later, such as the flow chart. We will be using the flow chart. We will be talking about the cause and effect diagram towards the end of the UML, organizational also. In addition, there is an option in eDraw, flow chart, for example. Here we can create different types of flow charts. Also, we have software tools. Here we can draw data flow diagram. We will be taking about data flow diagram in chapter 3. We can draw use case diagrams, very important for us. So all these types of diagrams we will be talking about, and we will be implementing using the eDraw. So we can consider the eDraw as a very important case tool for our course. There are many other case tools that exist in the market. Some of them are free, some of them are paid. For example, we have a software called the Visual Paradigm. This is a very important software, a case tool that can be used by software engineers to design various types of diagrams and software, but this one is paid. It's not free. Okay, so this is the notion of case tools is very important for a software engineer. Any software engineer will be using various types of case tools to design different types of software and to integrate designs together. Now, something very important is the case repository, which is a tool that can be used to gather different types of data related to a software project. So whenever you create a project, in order to organize the data that you use in the design and the outputs of the case tools, you can group all of the data together in a case repository. Here you can put the diagrams, the description data that you collected from the users and from the employees, the manual data that you have taken, your observations. You can write down all of that. You can scan documents and add them to the case repository. You can put here previous code that has been used and you plan on using it, integrating it into your software. So the case repository will be a single folder that will contain inside it all the data related to the design and data of the software. Nowadays, we can create a folder on Dropbox or Google Drive. Organize inside this folder, we can organize the data into categories and put each category into a subfolder. In this way, we can create a very useful and efficient case repository. So in the remaining of this lecture, I will talk about the agile approach, then the object-oriented approach using UML, briefly about each one of them, because we are going to discuss them in details in later chapters. Here you just need to know general information about them. Then at the end of the lecture, I will speak about which one of the three approaches is best suitable for certain types of software projects. First, with respect to the agile method or model for developing and designing software, the agile is based on three different main elements: the values of the agile model, the principles and rules of the model, and the core practices and the functionalities that you implement when you use the model. With respect to the values, there are four main values that are basic to agile, which are communication, simplicity, feedback, and courage. What do we mean by each one of them? Communication is a main and key value in agile, because agile is based on rapid and frequent communication between the software team who are designing and developing the software, and between all stakeholders related to the project. So if you remember from the previous lectures, we talked about the stakeholders of the project. In agile, there should be always frequent and rapid communication between the team who are developing the software and between the stakeholders. So you cannot here say that I will make a meeting between the various stakeholders each 2 weeks or each month. This doesn't work in agile. You should have a rapid and frequent communication. Maybe each 2 days you need to have a meeting. This is a core value and a main value in agile. The second value is the simplicity. Agile requires the software development team to work on simple cases and finish them, then move to complex cases after that. So agile doesn't focus on creating complex projects from the beginning. It focuses on simplicity, because in agile in general you have a specific time limit to finish the project. So within this time limit, you might not be able to produce very complex functionalities. So the main idea here is that agile focuses on the fact that let's try to produce the main and core functionalities at the beginning in a simple way. Then we can add the complexity that we require after that. That's why it is focused on simplicity at the beginning, simplicity first. This is another main core value in agile. The third core value is the feedback. So agile requires frequent feedback from the customer or the employee who is going to use the software. Because agile depends on incremental production, which means that I will talk about that later, which means that you produce the software in increments. So you need feedback about each increment in order to decide whether to stop working on the increment and move to the next one, or to update and work again on the increment to produce it better, or to include new functionality inside it. So feedback is very important in Agile, because you need always to check that what you have done so far is good and enough until this step, and the client or the employee approves what you have done so far. If the client or employee doesn't approve, you need to update what you have done so far, and then show it to the client or employee, and take his feedback again and again until everything is okay. Then at this stage you finish this increment and you work on the next increment. This is the third core value of Agile. The fourth core value is courage. Courage is important in Agile because in many cases the employee is faced with the option to make a certain delicate and important decision, which he or she, the software developer and the coder, should take this decision by himself. He shouldn't. He doesn't have the time, or doesn't have the. He cannot wait to show this decision or discuss this decision with stakeholders. So each member of the software team should have the courage to search the credibility, the reliability and credibility of various options, various decision options, and to decide by himself which one of these options is best for the software. So courage is also very important. If the software developer or the coder inside the team doesn't have the courage to take decisions, then he will not be able to work using the Agile method. Also, Agile requires certain principles or rules, and will have practices. We will discuss them in the next slide here. What are the main principles and practices of Agile? So these are general rules and practices that are used in Agile. The first one is that you should always actively involve the user. Means that the users who will use the software after it is finished should actively and frequently be involved in the outcomes that you are doing. Each time you produce anything new and you can test it, then you should show the result of the test and show what you have done so far to the user, and take his or her feedback in order to update what you have done and finish it, or continue to the next thing to do in the software. Also, as I said when I talked about courage, also the team should be authorized to make decisions, which means that each member of the software development team should have the authority to make certain decisions that he faces during his work or her work. Each one of the team shouldn't be afraid to take risks when it is necessary to take certain decisions about using a certain code or going on a certain direction in the code. These decisions should be taken by each member of the team according to what he sees best for the software. After that, if the decisions proves to be wrong, then this will be a good lesson for the team member to learn from this wrong decision and to correct it in the future. And this increment, what have been worked on so far, will be updated, where a new decision will be taken and a new increment will be generated for the user to check. Another rule in Agile is that the requirements of the project can evolve. You can change the requirements, you can update them, but the timeline or time scale is fixed. Usually in Agile, you have a certain time frame you must satisfy, which means that there is a deadline for each part of the project and for the overall software project, and you need to stick to this timeline very clearly. You cannot play with the timeline as you want, which means that if I say that if you specify at the beginning of the project that a certain task should be finished at a certain deadline, you need to finish this task by this deadline. If you delay this task, then you are delaying the whole project, which means that you should work more on the next steps, next tasks, to finish them by their required timeline. So usually Agile is used in most cases. When Agile is used, there is a specific time scale and timeline and a deadline for each task and for the whole project that should be satisfied by the software development team of the project. Another principle in Agile is that you develop small and incremental releases and then you iterate, which means that you divide the work of the project that should be done to finish the project into iterations and divide each iteration into tasks. And then you work on each task alone and finish it before you move to the next task. Well, you never start a task until you finish all tasks that precede it. When you finish each task, you test it, you make sure that it is working okay, you take feedback from the client or the user of the software about this task, and then you finalize this task and move to start with the next task. This leads to frequent delivery of products, which means that you will deliver the outcomes of tasks very frequent. Since you are developing the project in increments and you are dividing the project into tasks, then at the end of each task you deliver a certain outcome. When you combine the outcomes together, you will reach a certain product. So you deliver the product as a certain version of the product of the software. Then this product will be missing certain specific features and functionalities of the overall software, but it will be satisfying a certain requirement that you have focused on in this product. After you ensure and make sure that this requirement has been satisfied, then you move to another functionality or another requirement and work on the next during the next increment. So you develop the software in increments. In each increment, you have a certain functionality satisfied and finished, and then you work on later functionalities in future increments. This one we talked about. Also, you apply the 80-20 rules, which means that always expect that the last 20% of your efforts will produce the results, while the first 80% might not produce effective results. As I just said, that testing is integrated throughout the project lifecycle, which means that I don't wait until I finish the whole project and then I test. No, after the end of each task, I test that task, then I integrated it into the whole product and I test the product, and so on. This requires a collaborative and cooperative approach between all stakeholders, which means that everyone should be involved all the time in making sure that what is being done so far is correct and the project is on the right path. A stakeholder cannot wait until the project completely finishes and then give a view that something should be updated in the middle of the project. This will destroy all the agile process and will make the whole design model fail. There are four main resources that exist in agile projects, and the software developers, they try to balance these resources together. These resources, they have trade-off between them, which means that you cannot increase them or satisfy them completely, all of them at the same time. When you satisfy a certain one of them, you are obliged to somehow satisfy less another one of them. These four resources are time, cost, quality, and scope. Time is the total time required to finish the project. Cost is the total cost that you put into the project. Here it means the money cost. Quality is the quality of the project in general, of the software in general, and the quality of the services provided by the software. And the scope is the amount of functionality you put or you require in the project. The more functionality, the more outcomes and operations that are done by the software, the more will be the scope of the software. So when you increase one of these four resources, you can expect that one or more of the other resources will be affected. For example, if I increase time, if I put more time into the project, I can expect that I will be putting more cost into the project. This will decrease, which means that more cost will be put. Also, if you put more time on the project, you can expect that the quality and the scope will increase. You will have better quality and larger scope on the project. But this will come at the expense of the cost. The cost will be increasing. At the same time, if you decrease the cost of the project, you can expect that the quality and the scope of the project will decrease. If you put less cost, less money into the project, you can expect the software will be will be produced with less quality and with more limited scope. So all of these four resources, they have a trade-off between each other. Making one of the resources better or putting more into one of the resources might lead to decreasing or putting less into other resources. Now let's briefly see a brief overview about the 5 main stages of Agile as compared to the 7 stages of SDLC. We will be talking about these stages and how they can be implemented in details, I think in the last chapter of the course. The 5 main stages of Agile are exploration, planning, iterations until we reach the first release, then productionizing, and finally maintenance. These can be described in this diagram. As you can see, the exploration and the planning. Here in exploration, this is a very fast step in which you gather the requirements of the project, you analyze them, you develop a certain plan to how to do the design of the project, and then you document what you have done in a very brief and fast way. So we can say that this first step in Agile is done in a very fast way. If you compare this first step, it is usually done in the first 3 steps in SDLC. So the first 3 phases of SDLC, which are identifying opportunities, determining human resources, and analyzing the system needs, all of these, they are combined in Agile in a very brief phase, which is the exploration phase. So in Agile, you don't have time to go into details with collecting requirements, collecting data about what are the functional and non-functional requirements of the project, what do we need in the project, what are the objectives, and so on. In Agile, you don't have any time at all to spend a lot of time doing these steps. So you do the exploration in a very fast manner, because Agile is mainly used in projects when you want to design projects that you want to finish within a very strict time limit. The next step or phase in Agile is to plan the project. Here we mean by planning, creating the design of the project. So the process of drawing the design diagrams, designing the input and the output, designing the interfaces, and so on. These are done in the second phase, which is the planning phase. This can be compared in SDLC to the fourth step. So the design here is the planning and the Agile phases. Next, you develop the code of the software. The difference between SDLC and Agile is that in SDLC, we don't develop the code incrementally. We don't create part of the code, test it and finish it, then move to another task and create it and finish it, and then combine them together until we reach a certain functionality. When we finish this functionality, we are producing the first version of the product. So this will be the first iteration. So you test this iteration, you produce the first version of the product, which only can do a certain functionality only, and you take the feedback of the clients. This will be the first iteration. After that, after you finish this iteration and you take the feedback and everything is okay, then you start incorporating another functionality, another objective into the project, into the software. Then you start working on another iteration. So you finish developing the functionality, the code for the functionality, the second functionality. Then you produce the second version of the project, of the software, and you test it and you take the feedback from the client and so on. So here we are working in iterations. Each iteration will be responsible for a certain functionality of the project. In SDLC, we don't work in this method. What we do is that we can work on several functionalities together. We can divide the work between the software development team such that each member of the team can work on a certain specific task and different functionalities, and we don't have time limits for each task and each functionality. This is the difference between the way we develop the code in SDLC and the way we develop the code in Agile. When you finish putting all the functionalities and producing all the objectives of the putting all the objectives of the software inside the code, then you produce the first version of the software. So now, since this has been done in a rapid way, because these are done in very fast increments, this first version of the product or of the software will contain many bugs, and many features inside it will be incomplete. So you publish this version, you product this version, and you let the employees or the clients use this version. This will be some kind of testing rather than actual usage. So they are generally testing the software, not completely using it. So they tell you, they give you feedback about the bugs, about the missing features, about the incomplete functionalities. So you start again, you add these functionalities and you correct the bugs and you produce a second version of the complete software, and then you product the second version again, then again and again until you reach a state, the final version that you produce will contain no errors, and for a certain specific time it will contain no errors, and all functionalities, expected functionalities, are now working well. Then you product the final version of the software and you move to the maintenance stage. In the maintenance stage, you monitor the performance of the software. Whenever there is an error detected after that, or whenever a certain functionality needs to be updated, then you maintain the software and you add this functionality or you correct the error. This is in general how Agile design model works. There is a beautiful website, web page that shows you specific details about the differences between SDLC and Agile. For your general information, you can go over this web page to know more information and to detect the specific differences between SDLC and Agile. This is the link to it. This is another diagram that shows to you the details of this iteration. Whenever you work on iterations, how do you do that? The more details are given here. So you develop functionalities, as you can see. You integrate each new functionality, then you test. Okay, then you finish integrating all functionalities, you produce a demo. You collect client feedback, you make changes, and then you productionize the software and you put it into usage. Okay, if everything is perfect, you have produced a perfect software and no errors and no missing functionalities, then you release. If no, you go to the next iteration, as you can see here. Okay, and you keep doing this until you can put it into the market and release it. So generally, this was a brief introduction about Agile. As I said, we will have a complete chapter, which will be the final chapter in the course, to describe in details the main phases and the characteristics of Agile and how it can be applied in modern days for different types of software. Now moving to the object-oriented model. Also, I will not go into very specific details about the object-oriented design model and the UML design language, because we will have a complete chapter about them later. But we want to understand the specific characteristics and the specific distinctions related to the object-oriented model. The object-oriented is alternative to SDLC. It is generally used when we want to design a software, and this software will change rapidly according to the business requirements. So whenever you expect that the software will require rapid changes, dynamic changes, I know that this software will be updated very frequently. In this case, it is much more desired to design the software using object-oriented than to design it using SDLC. Something that is the difference between object-oriented and SDLC is that the design process in object-oriented model is works as follows. First, you take a complete system, then you divide the system into subsystems. Then you perform the design, the plan and the design and the implementation of each subsystem alone. When you finish each subsystem, you start working with the next subsystem. So here you can divide the complete software into subsystems, into parts, pieces, and you can work on the design and the plan and implementation of each subsystem or package of the software alone. When you finish, and you can work on designing and implementing several subsystems together, but each team can work on a certain subsystem independent of other teams. And you can, or you can alternately, you can make the whole team work on a certain subsystem until the subsystem completely finishes. Then you start with another subsystem and you work on it until it finishes. For example, supposing that I want to design a software system for a university. The software system will be a management system for the university. It will manage the process of registration of the students, creating courses, several courses, making the instructors assign the courses and assign students to courses. It will contain inside it a learning management system, for example. So I want to design a software that will manage all various operations that exist within a university. In this case, I can divide this software into subsystems. Each subsystem will be dedicated to a certain functionality. For example, I can make the registration process a subsystem by itself. So one of the subsystems of the software will be the registration. This will have the registration will have its own package. Inside this package, I will have all the classes and all the modules and functionalities related to registration. I might have another subsystem related to learning management system, which is used by instructors to create courses and put slides and videos and material inside them, and assigning quizzes for students and assignments and so on. So this can be another package in the software, another subsystem in the software. In case of object-oriented, usually what software developers and software engineers do is that they divide the system, the software, into subsystems. They work on planning and designing and implementing each subsystem alone. Then they integrate the subsystems together to reach the whole system and produce the whole software. In object-oriented, we use a specific language for designing the software. This language is called the Unified Modeling Language, or UML. As we saw in SDLC, there are phases for designing the software using SDLC. Also in object-oriented, we have phases for designing the software using the UML language. So the phases of creating the design using the UML language are: first, you define something called the use case model. So the first phase is the use case modeling. In this phase, you create a diagram called the use case diagram. This use case diagram can be created for each subsystem alone, or it can be created for the whole system altogether. So I can create a single use case diagram for the whole software, or I can create a use case diagram for each subsystem, and then I can combine all these use case diagrams together to create and reach a use case diagram for the whole software. From the use case diagram, I create something called the use case scenarios. We will be talking about the details later, but you can say that each use case here will describe a certain functionality, a certain operation or service offered by the software. For each use case, for each service or functionality, you create something called a use case scenario, which is a text file that describes the steps of how this service is implemented and used. Then after creating the use case model, you use this case model to create several UML diagrams, which are the activity and sequence diagrams. These diagrams, they put more details about the services and about the use cases. Usually, we use the use case scenarios to create the activities and sequence diagrams. After we finish this part, we use all the data that we have gathered so far, the use case diagrams and scenarios and the activity and sequence diagrams. We use all of that to create something called the class diagram. The class diagram will be the outcome, the main outcome of the UML design, and it is used directly to create the software, the code from it. In many cases, when we are dividing the software into subsystems, we create a single package for each subsystem, and we put a class diagram for, or we design a class diagram for all the classes inside this package. So we can create a class diagram for each subsystem, and then we can combine all these class diagrams together to draw a comprehensive class diagram for the whole software. This could be done and it may not be done. So we can reach the point at which we create a class diagram for each subsystem, and then implement these classes directly into code and use the connections and communications between the class diagrams to define the different function calls between classes of different packages and different subsystems. After creating the class diagram, before writing down the code, we create finally something called the state chart diagram. The state chart diagram describes the different states that each class can go into. Each class in the class diagram can go into different states. For example, I have a class called student. Each student can go into different states. At the beginning, the student can be initially a potential student. When the student actually applies for the university, you can call him a candidate student. Now, when the student is accepted, he is called an accepted student. Each one of these is a different phase for the student class. Now, developing these phases and connecting them together creates something called the state chart diagram. After we create the state chart diagram, we go over the overall UML design. We make sure that all the requirements and objectives that we have stated at the beginning of the design exist in the diagrams and in the class diagram. So we make the necessary modifications. Then we start developing, writing down the code of the different classes and connecting them together. And we produce also the documentation of the system. So these steps can be abbreviated in this spiral diagram, as you can see. We start by drawing the use cases, then we generate the use case scenarios, then we draw the activity and the sequence diagrams. From all of these, we create the class diagrams. Then we create a state chart diagram for each class that goes through several states. Then we review the whole design together and make sure that all objectives and all functionalities are integrated into the design. So we make the necessary modifications in order to make sure that everything is taken care of and included in the design. Then we start writing the code of the software and making necessary documentations. After we finish this cycle, then we start over by making the design of another subsystem of the system, and we continue this until we finish the design of all subsystems and we link them together to produce the whole software. These are examples of various types of UML diagrams. This is an example of a use case diagram. We can see here that it includes use cases. These are use cases, and these are actors. These are called actors, those who interact with the system and they start certain actions and invoke certain use cases. We will talk about that later. These are examples of activity and sequence diagrams. Also, we will speak in details about them later. I don't want you now to know the specific and complete details about each type of diagram. We will be talking about them in the UML chapter. Finally, this is an example of the class diagram. You can see each class is shown as a rectangle, and there are relationships, various types of relationships between different classes. We have composition, we have inheritance, we have different type of including relationships. We will talk about that later. The final thing that I will briefly talk about in this lecture is when to choose a certain method among the three. So when do I decide to choose SDLC, when do I decide to choose Agile, and when do I decide to choose object-oriented modeling to design a certain software. For each one of the three, there are certain situations which make this specific design framework best suitable for this situation. Let's see SDLC first. SDLC is best suited when previous systems that preceded this system were designed and developed using SDLC. So if you are developing a software for a company, and this software will replace a certain current software in the company, and the current software has been already designed and implemented using SDLC, and it proved to be efficient. So the design and implementation of the previous software that you are wishing to replace was successfully done using SDLC. So the management of the company, they might ask you to do the same thing and design the new software also using SDLC because they have previous successful experience with SDLC. In this case, you might consider using SDLC. Another condition or situation when SDLC is also useful is when documentation is very important. When you want to produce detailed documentation for each step you work on, you might prefer to use SDLC because in Agile and in object-oriented, they document what you are doing, but not to a high degree. While in SDLC, you document and create a documentation for each step and for each specific detail you are doing, very detailed. You put complete details into documentation. So if the management or of the company requires from you to produce detailed documentation, so you might consider to use SDLC. Also, SDLC require a lot of resources. Usually, the timeline or the time scale for SDLC in most cases is larger than that of Agile and object-oriented. So if the company allows you a large time scale and the full required resources to do the SDLC, then you might consider SDLC. SDLC generally requires a lot of resources to collect information, to define the requirements, to collect information about the various decisions that you want to make, to study the various decisions and reach a certain specific decisions. So these details, they are not focused on an Agile and on object-oriented, and usually you don't put resources into these details. In SDLC, you put a lot of resources into the design, collecting information, and creating various alternative decisions. With respect to Agile, usually it is used when there is a specific certain deadline to finish the project. Also, in order to use Agile, you need to have experts in working with Agile. So you cannot use Agile unless you have experience in designing and developing projects with Agile. The process of working in increments and developing increments very fast and testing them very fast needs huge expertise, and the software engineer is required to train on this expertise before trying to work with Agile modeling. When there is specific deadline, as I said, you work with Agile. Also, when there is a rescue operation, so suppose an error occurs and this error needs a huge change in a certain software, you need to modify a complete package, for example. You might consider working on designing the subsystem or designing the complete system using Agile, because you need to correct and putting into work the system very fast, as fast as possible. If the customer or the client or the user can be involved in the Agile, you can work on it. If the customer or the client cannot be involved, he cannot dedicate time for you for frequent meetings, he cannot be available all the time, then working with Agile will not produce efficient outcomes. Finally, with respect to object-oriented, when the problem is can be modeled using classes and the software will be developed using classes, then you can use object-oriented. If the project doesn't contain object-oriented behavior and look in it, then you will not succeed very well if you design it using object-oriented modeling. Also, you should know very well how to use the UML and how you develop various UML diagrams if you want to use object-oriented modeling. Now, some systems can be designed and developed and implemented gradually, which means I can design and implement each subsystem alone and then connect it with the whole system. Some systems allow me to do that. Some systems will not work like that. They require you to design and implement the whole software in a single step. You cannot divide the software into subsystems. In this case, you will not be able to work using object-oriented. Also, when you need to reuse previous code, so in some software, the major part of the code that you want to develop is code reusement, which means that you are taking a previous code and you are changing this code and you are using this code after you apply your changes into your system. When this previous code is a part of an object-oriented software, then you expect to design and develop the new software using object-oriented code. This was in general the difference between the three models and when is the best case to use each one of these models. With that, we finish the first chapter of the software engineering course. This was a general information chapter. We didn't focus here on any specific information. We took general information about various concepts related to software engineering. Next chapter, in the next lecture, we will be talking more details about specific design tools, such as the use case tools, the data flow model, and so on. Until we see you next time, thank you.